Welcome to Tech Info with Narsimha channel. Don't skip the video, see to the end. And like, share, comment, and subscribe my channel and press bell icon to get my latest video notification.
In this video, I am going to discuss about the analysis of simply supported beam with point load and UDL over half of its span. So you can see here, UDL is half of its span. The total span is 6 meter. In that, 3 meter is comprising of a UDL and another 3 meter comprising of point load. So we will do how to analyze this beam using the STAAD Pro software. So for that we have to open this STAAD Pro, new project. So you have to give a file name, you have to give a location, and you have to give a length units in meters and force units in kilonewtons as per Indian standards. Click next, and after that where do you want to go? So you can use these options also. So we don't need any of this, but we only need a beam. So after that click finish. So after that a node page will be opened now. You can see it taking some time. Okay, it's open now. So grid form, delete this, and we have to create a total distances. We have total distance of the beam is 6 meter. So first node creation, as you know, as you seen my previous videos. So I have created one node here, and the next node distance is nothing but from here to here. So it is 6. Enter. We can see 2 nodes has been formed. So we will view in plus jet. Then after we will create a beam by drawing a line from one node to another node. So I have created a beam now. The beam is successfully created now. Then after that we have to add the supports and other reactions. So that for that go to general. After going general, support reactions, create a support, pin support, add. So like this, assign to selected nodes. Yes. So supports has been created successfully. Then after, add load conditions now, load case details. Add. So here we are adding load 1. Okay, add. Close. So then add. So here we are assuming the member load is first of all it's a uniform load. For the uniform load we are assuming here is minus 30 kilonewton per meter. So the D1 is nothing but the end here from this side to this side. This is nothing but the D1. So here the value is 3 meter 3, and the D2 is nothing but the end from total from this end to this end is nothing but the D2. So here D2 is nothing but the 6, and here D3 is nothing but the endpoint. Endpoint is nothing but the 0 here. So after creation we have to choose the direction as global Y, then add. Then after we have to choose a concentrated force. So for this concentrated force we have taken as minus 50 kilonewton, and here D is 2 and D2 is 0. So you can see it has started from 2 and ended in 0. So after assuming the direction as global Y, add, close. So you can see 2 question marks here because we didn't add any load on this beam. So first of all we would add this UDL load here in this beam. Assign to selected beam, assign. Yes, you can see one question mark is gone, and now we have to add another question mark here on the same beam. Assign. Yes, you can see. So the scale arrangement is not properly. For that we have to go for the here loads. So you can see the same beam what I have drawn here. The same has been drawn here also. Then after we have completed everything, now just we have to give a section view. Section property we have to define. We are assuming the section as rectangular section, assuming the ZD value as 0.23 and YD as 0.38. So we can assume anything value here is just a section dimensions, and we have to assume the material as a concrete. Then add, close, assume the beam, assign to selected beam, assign. Yes, you can see this. Our beam is ready to analyze now. Go to command button, analyze, perform analysis, and no print. Then after run analysis, control plus 5 also you can type in keyboards. Then also it will directly go to run analysis. So save. So it's going to analyze. It is depend upon your computer speed. So 0 errors. Okay, now the program is success. So then after we have to, the main is we have to see the errors here. Error should be 0. If any error is there, then we have to recorrect it, and then we have to analyze. So next go to post processing mode, done, range. Okay, so you can see the beam here. So the beam comprising, you can see the beam, the displacement of the beam here. So for the results, for the value, we have to go to the results and beam results, and we have to add these all. It's your wish, it is your wish, maximum displacement, annotate. Okay, sorry. So we have to remove these all. We didn't know, we only need this, annotate, close. You can see the 19.411 is value. You can see from this also 19.411, the maximum value in the direction y direction. You can see it, minus indicates it's downward. So, and also you can see the shear force and bending moment diagram also. This is the bending moment in direction of z, bending direction. So you can see the maximum bending moment here is minus, and also you can see the result page as same as before. We're seen for the displacement, same u value, beam. Now you can enter these values. In before case we want to add only this one, so now you can add this also. Then you can see the value here at bending moment at simply supported ends is 0, as we all know about that. So the maximum at middle is minus 117.500 is the maximum bending moment occurring at the downward direction. So we can also see the shear force diagram. So the shear force value is, we can see here the shear force value is indicated in two, in negative and positive way. So we will see the diagram, shear force diagram. You can see this is the shear force diagram. You can zoom it properly, and you can see the diagram is like this. So you can see the values here, minus 84.1671 downward direction, and other is plus 55.833 from upward direction. So this is the shear force diagram, and also we can see the values of maximum axial force is 0 in this. So we'll see only these two on the deflection value, and also you can use see the stresses, what are the stresses involved in this area, and the maximum stresses and maximum profile stresses. So, and also we can see the graphs here. As you know, this is the bending moment, and the shear force diagram is like this. Is the values is here 5.8 and the minus 84.2. So this is the beam, this is the total analysis of the simply supported beam comprising of a UDL and a point load. Thank you for watching the video. Please like the video and share the video and subscribe my channel. Thank you.
Thank you. Please like and share the video and subscribe my channel.